Hello there. Today we're gonna get back on track and let's get some problems in. Um, this particular problem is it's a heap problem. It's called k closest point to origin. What we're gonna do here in our 67th problem is that we're gonna look for the number of the k closest items to the origin. And so basically, if there's one item, we're looking for the closest item. If there's two items, we're looking for the two closest items, and so on and so forth. And so to do that, we have the formula here, square root of x and square root of y to get to the origin, as x2 is always 0 and y2 is always 0. So it's basically x squared and y squared. And with that, we can add those together and get that's the particular distance. The further it is away, the bigger number, the further it is away, the closer it is, the closer the number. And so let's to do this most cleanly, we could just get all of these numbers and sort them in order and then pass each one out, but that would be n log n. But if we want to like make this faster, we could use a heap, which would be k log n, because every time we do a a pop, it will be a log n time, and we would just need to do this k times. Practically speaking, this is faster, but theoretically speaking, it is still O of n log n in worst case, because we might need to pop everything. Well, anyways, now that we're here, I mean, one way to just pop everything quickly is just return the whole list. That's something else. Anyways, I think that is an edge case that we can take care of, but the problem, let's get to the meat of the problem and get this. So one thing I saw after looking at Neetcode solution is that we could use this comprehension to do our min heap, which is much more clean for functional programming. So what we're gonna do is that we're gonna create a distance, a x and a y. That's our filler right now. We're gonna fill this in properly. Maybe we can come up with something that's more interesting in points and more readable. So I'm going to say distance equals let's say, I don't know, that's probably not going to work. Okay, well, for points and points, I was going to hope to assign x equals like 0.0, but that doesn't look very Python. So I'm just going to give up there. So we're going to do just points 0 squared plus 0.1 squared, and x is going to be 0.0, and we're going to make this more readable a little bit later. Let's just get this done for now. Right, so then what happens now is that we heapify the min heap. After that, while k is less than greater than 0, k minus equals 1 for every operation. And we're going to set the result is equal to an array that we're going to return. And we're going to just populate this array with the distance, x and y equals heap q dot heap pop of our min heap, and with that we want to add that item to our result, but append x and y as 1 unit, and we return the result. Alright, let's take a look. Looks like it's accepted. Let's submit. Alright, looking pretty good, not too bad. So let's clean up this code a little bit so that our next person reading this code will find it a little bit more easy to read. I think the best thing to do here is the xy. If we can get x and y here, maybe that will look better. Hopefully that works. I'm not sure. but if it does, it cleans up our code a lot, and it's worth a shot. And it looks like it works. Cross our fingers. Wow, it does. So it's a little slower, but we cleaned up our code, and we know what we're doing here. So perfect. Next thing we need to do is that if we can get the distance in there, but that is another story. It's another story. Okay, I thank you very much for watching. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. And I'll see you next time. Thank you.